Thanks for joining me, everyone. This is another of the Clean Code Nuggets, and this presentation will be the first of at least two parts to look at the subject of testing. So in this meeting, we're going to do a very quick recap of what clean code is. We're going to look at what a test is very briefly, look at various different types of test, some examples of testing, and then quickly go over the Python testing frameworks that there are. So a very quick recap of what clean code is. The best description I've ever come up with or come across is that clean code is easy to understand and easy to change. And that's what we're aiming for with our code. So going on to look at what a test is. In the simplest possible terms, you're testing something which we normally refer to as a system under test or an SUT. And a test is normally when you send a known set of inputs into the SUT, you should produce an expected set of outputs. And when you run the test, you're going to be producing a set of outputs. And if you compare those outputs to the expected outputs, if they match, you pass. And if they don't match, you fail. So you have a binary result to that test. You either pass or fail when you're doing that comparison. We do need to be a bit careful though. A test only indicates whether the tested functionality is working. So you're only proving that one thing is being done correctly. It doesn't indicate that all the functionality is working correctly. So if you don't have sufficient tests, you cannot rely on your tests to tell you that your code is actually working correctly in general. So going back to our definition of clean code, how do tests help us keeping our code clean? Well, firstly, tests make things easy to change. If you make a change to your code and all the tests pass, then you know that you haven't changed the existing functionality. So making a change, if you break a test, you know you've probably done something wrong or your tests need to be updated. And obviously you'll need to add tests if you add some new functionality. But secondly, the tests do help you to understand the code. The tests, they give you examples of how the code is called and also examples of expected outputs that you get for certain inputs. So they'll help you in two ways, tests, both to keep your code easy to understand and easy to change. So in general, what should a test be? Well, we want it to run quickly. If tests don't run quickly, then you're going to be frustrated. You're going to be sitting there waiting for them to run, and at best it's going to be a waste of time. At worst, you aren't going to run the tests, so they'll be useless. I know that we've got some MCP tests that run and take 15 or so minutes to run, so we don't tend to run those very often. Secondly, you need your tests to run easily. They need to be basically at a press of a button. You don't want to be doing lots of setup to get those to run. Otherwise, again, you're probably not going to use them. Thirdly, you really want them to run automatically. You don't want a human to have to sit there and press different buttons because that means that firstly, there's the added ability for the user to make mistakes. But secondly, you want your tests to be able to run, say, on a build server without a human being there. So you definitely want them to be automatic. We also want them to be able to run repeatably. If the tests produce different results in different circumstances, then they're not useful. And I'd go as far as to say that they're actually worse than useless because they can give you false positives or negatives. And also we've come across situations where tests have to be run in a certain order. So if you don't run test 1 before test 2 will fail. Again, that's not ideal. You really want your tests to be completely isolated and completely independent so that they can be run repeatably. We definitely want our code to be clean. We want it to be the code of the tests themselves. You want them to be easy to understand and easy to change. And you also want your tests to fail if you change the functionality of the system under test. So if you make so you change a calculation, you would expect your tests to fail. If they don't fail, then there's something definitely wrong with your tests and you should write better ones. When you have a test, you do want it to, or you want to easily be able to identify why the test has failed. So if you're just getting a Boolean response to say this test has failed, it may not actually be very useful to you. You might want to add some further text that's reported by the test to say it's failed because this value is too great or too small, or it hasn't produced this text file, or whatever the reason for the test failing would be. And you also want to be able to test what, or to know easily what functionality has actually been used. So you can, if you realize the test has failed, you want to be able to drill down, look at and find the code that has failed, and that should make it quicker for you to understand what the test is doing and what code has actually been used. You also want to make sure that it's clear from the test what the expected functionality is. For example, if you're checking that a calculation result is correct, you probably want to include details of the calculation in the test rather than just having a result value that's in there. We'll come on to discussing that later though. And finally, you want your test to be relatively robust to any refactoring that you're doing of the system under test. This is because you're probably going to be making some changes to the system under test. So you don't want to be tied to the internals of it, but you probably want to just deal with say the public functions. And if you do change the public functions, you're going to have to go and change lots of other code anyway. But if you tie your tests to the internals of the system under test, then you're putting up a barrier to refactoring those classes, which is not ideal. Does anyone have any questions or comments on that?
The second last point there, Stephen, make clear what the expected functionality is. Do you mean in the test itself, or?
Yes, in the test. So if you are checking a calculation, so you're adding two numbers together, for example, rather than saying just giving a result that you're checking, you'd actually do the expected result being the sum of those two numbers. That's obviously a trivial example. When you get to more complex examples, it can be quite difficult to do that and still keep your tests readable. But the idea is that you're trying to explain something within the test itself. Is that okay, Ian?
Yeah.
Great, thanks for that. So one way that you can make the tests more readable is to follow what's known as the AAA pattern. Those A's stand for arrange, act, and assert. Arrange involves the setting up of any items that you use in the test. Act is the calling of the functionality that you are actually testing. And then assert is checking that the results are as expected. So if we look at a very simple example, here we have a very, very simple user class where in the constructor we're passing in the first and last name, and we have one function, name, that returns the name of the user. And then we have a very simple test of that, which is broken down into 3 parts. It starts off with the setup of the first and last names and the expected result, which is the arrange part. We then have the act part, which is actually calling the constructor and the name function on that instance, returning an actual name. And then finally, we've got the assert part, which is checking that the expected name and the actual name are the same. And if we always try and include those 3 parts to a test, then it makes it much easier to understand what's going on in the test. And so hopefully you're going to get better quality tests. So that's a brief introduction to what a test is. Let's move on to looking at the different types of test. So if we imagine we've got a set of source code here, would anyone like to venture an idea of what the different types of tests are that we have?
Unit tests?
Yep, that's the lowest level. We have unit tests, and we're likely to have lots of those.
It's an end-to-end test? Probably
Yep.
got a different name?
That's one of the other ones. But it won't appear next. So yeah.
Regression?
Regression tests, that is a type of test, but I think that what I'm referring to here is the different, if you like, the different levels of testing. So you can run regression tests on unit tests even, to check that the unit tests are doing what they did previously.
So integration tests.
Yep, that's the next one up on the list. Well done, Stephen. Thank you. And then system tests is really another way of describing end-to-end tests. And then finally, right at the top level, we have acceptance tests, which we'll come on to discuss. They're very similar to system tests. But those are the 4 different types of tests that we're looking at. And whoever said regression tests, yes, that's true. But you tend to run regression tests on one of these different types of test, this level of testing. So we'll come back to this diagram a little bit later, but let's have a little look at unit tests and look into those in a little bit more detail. Unit tests are running a test on an individual function. Those tests are they're defined and owned by the programmers. And when we talk about the ownership of a test, we mean who has the permission to create them, alter them, or delete those tests. From a unit test point of view, that's the programmers. So if the programmer makes a change to the code, they have permission to change any of those unit tests. It doesn't mean that the programmer should change any test, as a failing test may mean that you've broken some of the other functionality, but you have the permission to make changes to those unit tests. Unit tests are normally functional testing, and when I refer to functional testing, I mean that you're checking the results are correct. We'll come on to talk about different ways of testing. For example, regression testing is not necessarily functional testing. It's another different kind of testing. One of the frequent questions that we have is how many unit tests should we have for any function? And it really depends on the complexity of the function. And the normal guideline rule is that you should have at least 1 unit test for every execution path of that function. Again, we'll come on to discussing that in a little bit more detail later on. when we have a look at an example. And you also, as we're only testing the functionality of the function itself, you want to keep those tests independent from other code. So if your function is making calls to external classes, then we want to make sure that we're not testing those external classes. And that's where we can use things like mocks to replace other code. But we'll come on to talk about mocks in a bit more detail later on as well. So the second level is integration testing. For integration tests, you're testing a combination of functions or objects, and you're testing the interaction between them. So if, say, you've got one function that calls something else and that makes a call to the third thing, you're testing how those three objects are working together and making sure that they are working together as expected. Again, it's functional testing, so you're testing the result that's created when you run one of those functions. And as with unit tests, the ownership sits with the programmer, so they have the right, the permission to go and add new tests, change existing ones. Similarly, we only want to be testing the set of functionality that the integration test is covering. So for anything outside that set, you're going to want to use mocks to keep it independent. And that's it for integration tests. System tests are the next level up, and here we're testing the whole software system as a whole. So it's an integration test over the whole of the software. You can run system tests to test different aspects of the system. Similarly to unit tests and integration tests, you can run them in a functional way, so you're checking the outputs of them and making sure those outputs are correct. But you can also run them, for example, to test the performance of your system. Are you calculating things within a certain set time? There may be a number of other requirements that you have. For example, you might want to make sure that you can run the system can be run by 4 different users at the same time. You may want to have a system test for that. So there's lots of different ways that, or reasons why you may have a system test. As with the other tests that we've talked about, unit and integration, again, the ownership sits with the programmer. So it's up to the programmers to create, edit, and delete these tests as appropriate. And again, you may want to use mocks to keep things independent from those outside the system under test. In this case, that would be things like the file system, or if you are writing your results out to a separate database, you probably don't want to be used in the live database, so you might want to either use a test database or mock it out to something separate. So you're replacing that database with a mock. And again, we'll come on to talk about mocks in a little bit. And then finally, we have acceptance tests, which are almost identical to system tests in that they act on the system as a whole. And you can run them to test different aspects of the system. The main difference here is that those tests are defined and owned by the product owner of the software. So as a programmer, you shouldn't be editing those tests. If one of these tests fails, it means that you've probably broken the functionality of the software, and that's a big red flag. You're going to need to understand why that test has failed and start to discuss that with the product owner to make sure that the change that you've made is actually valid for that software. And we're doing this to protect the overall functionality of the system. These tests are often used as a definition of what the code should do. Or another way of putting it is that you're confirming that the code is functioning as required. So it's a top level definition, sometimes created by the product owner, of what the software should do. So if you break them, the software isn't doing what it's been defined to do. And similarly, as with the system tests, you may want to use those mocks for other aspects of the system, other aspects like a file system or an external database.
Hi Steve, I have a question on acceptance tests. Just going back to your definition of what a good test looks like, one of the things that you highlighted was that it runs automatically and
Right.
without manual input or, well, any manual actions required, I guess.
Mm-hmm.
This I can sort of see how that would work for the other types of tests, but I guess for acceptance tests, I'm struggling to imagine what that looks like.
Well, it depends what the system is that you're testing. If you're thinking of a bit of software that has a lot of user interaction, something like MCP or WF Yield, one of our larger bits of software, that it can require a little bit of changing. So, for example, WF Yield, you can provide it with a set of command line options that will run the software in a certain way. So you can provide the input files, the files that it's going to actually calculate on, and any calculation options via command line arguments. And that will take the human aspect out of it so that it can be automated. But you're right, it can be quite difficult.
I guess like there's a couple of other examples too. So like the VAM has some automatic acceptance tests. It's kind of a scripted type thing. There's a sort of set of instructions in like a JavaScript file, and they essentially click buttons on the UI of the VAM, and then they check that certain things have happened, like a certain turbine appears or whatever, that sort of stuff. And then like as long as all those things have happened, it says that's okay. And it does it like it can create a video of that as well. So you can go to sort of a dashboard and you can see a video of like the latest release of the VAM and what happened when these tests were running. So that's one way of doing the acceptance test. That sort of test is normally written by a programmer though, so it have to be interpreted from like the wishes of the product owner. I guess the other example is the old economic model. So the tests there were written in Excel. There's then some code that turns it into C# sort of automatically, and that C# is then just test code. So it just ran those tests. So essentially, more or less, it ran against the Excel spreadsheet and asserted that the inputs in the Excel spreadsheet, when you calculated them, the C# outputs were the same as the Excel outputs. And again, that is automatic. And in that case, the product owner does write the Excel, so it's kind of quite good.
But I think what you're getting at, Lee, is that sometimes it is very difficult to write these automatic tests, and it can require some refactoring of the code to allow it to be tested properly. If you're not thinking about testing when you're writing the code from scratch, then you can get to a point where you suddenly think, hang on, how am I going to test this? How am I going to write acceptance or integration tests to do this testing? And it can be difficult to do that. And in fact, in what I'm planning to do in the next Clean Code Nugget is to go through an example of some code that isn't tested at all, and go through the steps for how we'd actually start adding tests to that code. Does that put your mind at rest on that, Lee?
Yeah, that sounds really useful. I guess one of the reasons I was asking is that, like, I think some of the analysts are pretty good at writing tests on like pieces of calculation logic. You know, some numbers come out or some numbers go in and some calculation happens and an expected number comes out. But then when it comes to testing something like, let's say, a user interface or an API that we've made that we're gonna, deploy somewhere. We're comfortable. Let's say we make an API that the calculation sits behind. We're quite comfortable with testing the calculation logic, but maybe not so clear on how we should be testing the deployment of the API and that calls to the endpoints are working and that kind of thing. So I think some guidance on that would be pretty useful.
Okay. Yep, that's true. What I will do after this presentation is we'll try and get together some advice on that, get some links together, and we'll put those in the Yammer group.
Awesome.
Have you used any of the frameworks for testing the UI, if it's a web-based UI?
Yes, I think that said. Do you know what we're using when we're testing the RAM?
We used to use Nightwatch, which is based on top of Selenium, which was all right actually, but we now use Cypress, which is much better.
And that runs in Chrome, isn't it?
Yeah, headless, runs headless on Chrome. Yeah.
Yeah, we'll include some links on that in the notes on Yammer afterwards.
Lee, maybe, do you want to give us a couple of examples of things to talk about, like example repo with these sort of things in?
Yeah, we can do. I think we've got one specifically where we've got an API for that has no tests of the API part, so we could run that by you after the call, or...
Yep, that sounds good, Lee. If you want to pass those over to me, we'll look into that.
Thank you, Steve. Thanks, Ed.
Okay. So if we go back to the diagram that we had earlier, we've gone over the different levels of testing now. And each level of test is working on a different amount of code. So unit tests are working on a single function. As you go further up, integration tests are working on a set of those, and the system acceptance tests are working on the system as a whole. A side effect of this is that the ease of writing those tests is the inverse of this. It's very easy to write unit tests because you're just looking at one function. But as you start to move up to integration tests, they're a bit more difficult to write, and acceptance and system tests can be really difficult to write to produce correct outputs, and also to be understandable and maintainable. However, there's a flip side to this. The tests that are the most difficult to write are also the ones that give you the most confidence that the software is working. So if an acceptance test is working, you know that your end-to-end software is doing what you expect it to. And that's very important, and which is the main reason why we have acceptance tests. But it's also important to run these tests in a certain order. If there's a fault that's been introduced somewhere in that system, then you're going to get failures probably a number of these different levels of testing. You'll probably get one or maybe more unit tests failing, probably, hopefully, an integration test, and maybe one or more of the system or acceptance tests failing. If you were to just run the acceptance tests, you wouldn't have an idea of what that code is that is failing. So if you're running the unit tests first and one of those fails, you can identify quite easily what the code is that's gone wrong. It gives you a much better idea of where to start looking to fix that fault. So it's important to run these tests in a certain order and look at them in a certain order. Any questions on that? I'll take that as a no then. Okay, let's move on to looking at some examples of tests. Here we have we're going back to the simple user that we've seen previously, and we've got a very simple test on it that we've seen previously as well. So how many tests do we need to test the name function?
One.
Yep, we've got one path through the code. We're just the function just has a return statement. So having one test on there, that's the minimum that we need to test it. We can obviously have more tests, but that's definitely the minimum. Now, if we update the simple user to include the addition of a nickname, and we update the name function as well. So if we include the nickname, then we're including that in the output of the name. But if it's not there, then we just return the name as it was previously. So the same question: what's the minimum number of tests that we need now?
2.
Two.
Yep. 2 sounds good to me. We've got 2 paths through the test, and so we should end up with 2 tests. And we've got the test of the name with no nickname, when we're providing just the first and the last name, and we're expecting to get that result out. And then we have the nickname, where we provide that in there, then we're expecting to get the combination of first name, last name with a nickname in the middle. So again, we've got a couple of very simple tests here. Obviously, we might want to test more elements of this, but this is the minimum that we'd need to go through. So if we,
Steve, sorry,
go ahead.
could you go back to the last slide? So one thing, I don't know how I would squeeze it into this example, but one thing I have a tendency of doing is layering in error handling.
Yep.
So for instance, if a user gave you an input that was in some way incorrect, I'll try to catch that. And what I usually do,
we are going to come on and talk about this in a couple of slides' time.
Sorry.
So, it's a very important thing to point out in terms of catching errors on the input, and then how we test those.
Because this is Python, right? So it's possible that like the first thing, the things you pass in are strings, and then this would break. Can I take it? If you passed in. Thing.
No, if you passed in a date for the first name, this would still print out the date.
Because the format function would work.
Yeah.
But you're right. Yeah, we should have some testing on the class in terms of the items that are passed in. Make sure they are valid, and in a couple of slides' time, we will actually come on to talk about that very briefly.
Okay. Sorry.
That's okay. Any question is a valid question. Well, within reason. Okay, so if we extend the simple user class a bit more to provide the birth details of the user and a function that calculates the age or their current age, and yes, maybe this code isn't the best in the world, but it demonstrates the example that we're trying to get across here. So if we're trying to test the age function, in this case, there are 2 paths through the code, whether we go into this if loop. So you could argue that we should just have 2 tests where the user is born earlier in the year or later in the year, but we have an edge case here. So we have the case where today is, or that the user is born on this day of the year. And so we probably want to test that edge case as well. Edge cases are always good to test. So we have some tests here where we're passing in a date that's earlier in the year, and we're testing that. One that's later in the year, we're testing that, checking that we've got the right expected and actual ages, and where it's the same day, they're born on this day in a previous year and checking that we've got the same expected age. Now, can anyone spot the obvious problem with these tests that we've written? Or maybe it's not that obvious.
There's quite a lot of irrelevant information.
There's quite a lot of irrelevant information, and we can obviously, what I would do is to refactor the class in a different way. But there's something much more problematic about this.
Depending on what data you're in.
Exactly. Yeah. These tests aren't repeatable. If we ran that first test on the test age born earlier in year on the 1st of January, we're not testing that it's born earlier in the year. We're testing it's a repeat of born on this day. Similarly, if we were to test this test age born later in the year, if we were to test that on Christmas, it would fail. So what we've got here is a test that isn't repeatable. And I think you're right, Sid, there's a number of other problems with these tests. But the fact that they're not repeatable is the overriding problem with these tests. And we can change these to make them more repeatable. For example, we can base the tests on the current date. So what we're doing here is we're using subtract month from date, which is a separate function which I haven't included here, and add month to date, where we are then calculating the values that we should be using for the year, month and day of birth, passing those in and making sure that we get the expected age.
If you add more functions, would you not need to test if the new functions are working?
I think you are identifying a real problem with these tests, that we need to then test that subtract and add month to date code. But I think fundamentally this is identifying that the real problem here is that potentially we should be refactoring to make this code easier to test. And these tests are getting more difficult to read. So the solution that I would use is to use mocks. We do some refactoring of the simple user. So we have a separate class, current date time, and all that does is just return today's date. And we pass that in to the simple user as this current date time. Again, probably not the best named. I would probably call that current date time factory. And when it's passed in, if it's not provided, then it just uses an instance of that current date time class. And in the constructor, we're using that to call the today function, get the date, and save it into a member variable. And then when we're calling the age, we're just comparing that to that today value and calculating it from there. Now, by using this idea, we can easily start to use mocks. And the idea of a mock is that you are substituting the behavior of one object with some other code that is specific to the test that you're interested in here. The syntax is different depending on which Python testing framework you're using. This first example that we have is for unit test, and you can see that we're setting up a date, which is what we want to use for today. We're then calling that unit test.mock to create a current date time mock object, and then we're stating on this line that for the today function, when that's called, we want the return value to be that today variable that we've already created. So that today is the 2nd of September, and the date of birth that we're using here is the 1st of September, 19 years ago. And we can then simply call the simple user class, providing the mock current date time object that we created. And we expect our age to be the 19 that we're passing through there.
Hi, Steve. I have a question on this specific example, which is you've kind of refactored the class, as you said, to take this current date time as an optional argument.
Yep.
Enable you to write the tests in a different way.
Yes.
I guess that kind of, so that's a benefit, obviously, but to counter that, it kind of makes calling the class more complicated, and it adds another execution path maybe, or it gives a user who's using that class the ability to use it in a way that's not intended by providing current date time. Feels like something that you shouldn't optionally
do. I think on one of those points, there's quite a good default implementation of that. Like you can just use datetime.now or whatever the Python thing is for that. So
yeah.
You can do that in the code, right? You can have a default parameter, so you can just pass in nothing most of the time. So your test code passes in the mock thing, the rest of your code passes in nothing at all, and it just uses the default.
Mm-hmm.
I think that probably addresses your first point. The second bit about it being able to be abused, I mean, it's a fair point. You could pass in something weird. I kind of think you probably wouldn't, though, in this case.
But what we're also showing here, Lee, is the idea that you're trying to pass in to the class things that it depends upon sort of implicitly. So the class that we had before, it implicitly relies on that date time today functionality.
Yeah.
So it's got a dependency built into it, and what we're doing here is to try and break that implicit dependency by making it explicit in the constructor. And you're right, it does, as Sed mentioned, it does give the ability to potentially break the software, but there is a good reason for doing that. And obviously this is a very trivial example, but if you were doing something like writing to a database, you'd use this approach for injecting the dependency in the constructor. Would be the cleanest way of doing it.
Yeah, that makes sense. The other question I had, I've never seen this unit test .mock thing before, so when I've done a mock previously, I've just kind of defined a new class called mock, whatever the thing is, and give it the attributes that it needs. What does that mock thing actually do that's different?
Well, it's making sure that you don't have to go to the bother of writing a full new class to enable that testing. Which is, you've got quite a bit of overhead in writing that code, and also you could get that code wrong, and you could get your implementation wrong or slightly wrong. So these mocking libraries, whether you use the one in unit test or the one that we've got here, which is using the PyTest mock library, which is the syntax is slightly different, but what it is doing is it's trying to make it simpler for you to perform that basic action of providing something that has the same behavior or the same interface but a different behavior, and allowing you to plug that behavior in easily when you're writing the tests.
Yeah.
So can I ask a question, Stephen, whether something would be acceptable? Obviously, what you're demonstrating here is using mocks. I can see that.
Yeah.
Another way of approaching this, and I don't know if this would be considered acceptable or not, would be to have another function, age@date, which passes in the birthday and the day you want to consider, and then have a one-line function pass calling that function with today's date, which doesn't itself have any unit tests on it.
Yep.
Would an implicit, a very, very simple one-line function without unit tests, would that be considered unacceptable, or would that be another acceptable way of doing it?
Personally, I think from a pragmatic point of view, that would be an acceptable way of doing it.
In this particular case, I obviously understand you're giving us a simple example to use mocks, but in this particular case, that would be a much simpler implementation.
Yes, yeah. I think what you're pointing out, Ian, is that there are lots of different ways to implement something, and although I think if you're going to take a completely rigorous approach to it, then having some function that isn't unit tested, is a bad thing. But we need to take a pragmatic view of this. If you've got other code that is testing the functionality without actually making a call to that function, the base functionality is tested and rigorously tested, then we need to take a pragmatic view on it, that it's probably acceptable. As long as you understand what the repercussions of that are, then personally I'd say that was acceptable.
Okay, thank you.
And to follow on from your point, Ian, I agree. The example that we've got here is a terrible way of doing it from the simple user class, but it is just an example to try and point out in a simple way how mocks can be used.
Steve, I can't see very clear the screen.
Okay.
So can I join through Skype?
Sorry, say that again?
I can't see the screen.
Okay.
So can I join from my desktop?
Yes. Yeah, you should be able to. Yeah.
Okay. Yeah. Okay.
Then there were two.
So do we have any other questions about mocks? I'll take that as a no. Okay. So moving on to looking at exceptions. Stephen, I think this potentially is covering the point that you were making about passing in values and making sure that the values are correct. In this slightly different case, we are adding some checks to the constructor, making sure that first name and last name are actually provided and they have a length. If the length is 0, then we're going to raise an exception. Again, it's maybe not the best way of doing it. There's lots of different ways of doing it. But the code that we've got here is just to demonstrate how you would run a test and check to see whether those exceptions are being created. So if we have a couple of tests in here, again, this is the PyTest way of doing it. If you had a blank first name in the first test or a blank last name, we have this particular test. So we're checking to see whether a simple user construction exception is going to be raised, and we call that, we run that functionality. So I guess you could say that the arrange, act, assert pattern is slightly different here in that the act and assert are combined together on these particular lines. But hopefully it's relatively easy to understand what's going on there. We're expecting a simple user constructor exception to be raised, and if we run those tests and it's not raised for whatever reason, then that test itself would fail. Was that what you were getting at, Stephen, when you wanted to the point that you raised earlier?
Yeah. No, that's exactly it.
Okay. So moving on to the final example of tests, there may be cases where you want to run the same test but on more than one value, and we can do that using parameterized tests. So we have a simple example here of a function, is this number even, that checks and returns whether the number is even or not. And within PyTest, this is the way that you define a parameterized test. We've got a value called x, again, a terrible name for a variable, and we're providing 6 different values here, and the test is this number even? And we're providing an even set of values in there. And similarly, we have another test, is this number even, number is odd? Again, probably a very bad name for a test, because it's quite difficult to understand what's going on there. Again, we're providing a variable called x, probably the worst name that we could use. And we're providing lots of odd numbers in there, and we're expecting the is this number even function to return false. So that's the 2 sets of parameterized data that we're passing in. And when we run this through, this is the results when we run them through in PyCharm. You can see that we've actually run 12 tests. So in terms of code, we have 1 test with a set of parameterized values, but we're actually running through 12 separate tests, 6 on this one and 6 on this. I think if I was to rewrite this, I wouldn't use the term x. I would use even number that would then be passed through, and it'd be more obvious as to what's going on. And in the second test, it would be odd number, which would again make it more obvious what's going on there. Now we do have to be quite careful though, because as we've just shown, parameterized tests can be harder to read. In this case, we're only passing in a simple set of data, but if you were passing in a lot more data in a parameterized form, these tests can become very difficult to read. Possibly one of the ways of doing that is making sure that you use sensible names, which is why X is not a sensible name, and that can make them more easy to read. But it's just something to bear in mind when you create these parameterized tests, that they can become more difficult to understand. Any questions on that? No, thank you. Right, so we're going to have a quick look now at the Python testing frameworks. It's not going to be very in-depth, but there are 3 main testing frameworks that I've seen people using. The first of those is unit test. It's probably the first testing framework that people come up with because it's part of the standard library. You don't have to install it to use it. And on the positive side, it's got unit test.mock included, so you don't need to install that. However, you're going to need a separate test runner. Unit test itself doesn't work as a test runner, so you're going to need to run something else in order to get those tests to run. The second testing framework that most people have come across is PyTest. Now, it's not part of the standard library, so you've got to actually install it. But on the plus side, it's probably the most commonly used. in the industry, especially in open source projects. It can itself act as a test runner, so you won't need anything else there. It also allows you to run unit tests through PyTest. So if you're moving from unit test to PyTest, it eases that transition. And it has potentially a simpler syntax in that you don't have to create test classes in order to create those test functions. So it can be clearer to write those tests. And the final one that I've seen people using is nose, which is no longer supported. So we shouldn't be using it. We definitely shouldn't be using it for any new code. If you've got existing code that's using nose, that's fine. But if you do come to add new tests, I'd seriously ask you to consider looking to port your tests over to one of the other testing frameworks. So in summary, I wouldn't use nose. PyTest is probably the testing framework that we'd recommend you using if you're not using any at all. But unit test is there, it's working, it's supported. So you can also, using that would definitely be okay from our point of view. Any questions on testing frameworks in Python?
Steve, it's interesting to distinguish between a runner and the framework itself. So what's quite nice to say is that PyTest will run all unit tests and it will run anything previously that you'd written with like the nose syntax. I'm not sure nose will run PyTest's stuff, maybe. The parameterized thing might not work, I'm not sure. But most of the time, if you've got tests that are, the test code doesn't often look very different, but you can run it with PyTest or nose equally. Yes. I think people are a bit confused on that. So what else is there to the framework apart from the runner aspect of it? Is it just the way, the syntax basically that you use to write the test is different?
Yes, so there are quite a few details of the syntax that are different in unit test and PyTest. If you are adding tests in unit test, you do have to create a test class, which is probably the other big difference between the two. But they all have their differences. I think because the majority of the use is moving towards PyTest in the open source community, that's probably going to be the testing framework that's going to be supported for longest. And that's an important consideration if you're writing code that is going to be around for quite some time.
Yeah, so PyTest tests can just be functions, right? Whereas unit tests have to be inside a class. That's one sort of difference, isn't it? I'm sure there's others too if you look at the docs.
Yeah. There's quite a few differences in terms of syntax and the details of how it can do different things. I'm not proposing to go into too many of those details in this call, though. I think that at the end of the day, though, if you're using unit test, that's fine. Keep using it unless you have a really good reason to port things over into PyTest. But if you're using nose, you should be on warning that it's no longer supported, so it could go wrong at any time. So you've got that danger, that risk to your tests. So that was kind of almost a little bit of a dodge of answering the details of your question, Lee.
No, that was a good answer. Thanks, Steve.
Okay. Anyone else? No? Okay, well, let's quickly summarize what we've talked about here. We've briefly looked at what a test is. We've looked at what a test should be in general terms. We've looked at the different types of tests that we have, the different levels of testing. We then quickly looked at some of the examples of that, specifically looking at mocks, exceptions, and parameterized tests. And we've briefly gone over the Python testing frameworks that are commonly used and which ones we'd recommend. So that's it for this first Clean Code Nugget on testing. Does anyone have any questions in general that they'd like to ask?
Steve, this is more of a comment. I'm not really quite sure what I want you to say, but we're trying to update the WinFlow tests at the moment, and if we followed everything you've just said, and we're in nose tests, and then we need to refactor all the codes, it just seems totally overwhelming. I don't know if you've got any comments on that.
It's true. When you sometimes look at tests and you think, where do I start? I think it's similar to any code, that you shouldn't just go in and refactor things for the sake of refactoring things. If you've got to go in and change any particular piece of code, then that's always a good opportunity to look at that code and think, how can I make that better? So if you're revisiting one particular test on the WinFlow code, you might want to think about, am I following the AAA pattern on this? Can I change that particular test to be more readable by breaking it up into different sections? But don't try and go too far in any one refactor. So try and keep things simple, step by step. It also means that you can commit that change back in, and give you those simple bit by bit incremental changes. But unless you've got a really good reason for updating all the tests at any one time, then it's definitely not worth going for that big bang approach. Take things in small steps. If you're looking at a test and you don't understand something, that probably means it can be a better test, and you might actually, in order to understand it, a little bit of refactoring will probably help you to understand it. So take things little step by little step.
Okay, that makes sense. I think we just need to add so many more tests as well, and obviously, and I don't know how we can do them quickly, but we're talking about that with Sed, so
yes,
we'll get there. Anyway, lots to bear in mind. Just not quite sure how we achieve it at the moment.
The other thing I found, like changing between nose and PyTest, because I've had this come up before, and it's always been like no one's quite clear of what it means, and that's why I was asking about distinguishing between the framework and the runner. So, if you've got a load of tests that work and you're calling them nose tests because when you run them, you're just executing nose tests at the command line. But if you're not in the code, if you're not importing nose as a package and using the functions that it has, then it's as simple as just instead of typing nose tests at the command line, just type PyTests at the command line, and it will just work in the same way that it's always worked, but it will run with PyTest instead.
That's good to know.
The only time you'll actually have to, or that it would be recommended to change your code, your testing code, is if you're like from nose.tools import assert this is greater than equal to that sort of thing. If you're using those kind of nose tools, then people would recommend that you stop doing that. But otherwise, you don't actually really need to change your code too much, usually, or at least that's what I've found. Like if you just have a function that is testing an input versus an output, and then using the assert statement in Python, then that would look the same if you wrote it to run with nose or to run with PyTest, usually.
Guys.
So I think, Alice, what's probably a good approach there is to understand where you're trying to get to in terms of your testing. If you're trying to migrate away from nose to something else, if that was your main objective, then it would be good to try and try and understand what the steps are to get you there and get through those steps one by one. Whereas if you're just trying to improve the quality of the tests in general, if that's the requirement that you have, then you can think about when you come to look at a particular test, breaking it down, following the AAA pattern, for example, or renaming variables to be more readable. So there are various steps that you can take. Don't try and bite off too much at any one time, I think is the key lesson.
Thanks. That's helpful.
I think a comment I've got, Steve, and again, it's not really a question as such, and it's maybe quite in line with Alice, is anytime I've kind of written tests, I guess it's always been a little bit, not an afterthought, but maybe a little bit reactive at the end of, oh, I should write a test for this. Mm-hmm. When you, maybe, I think that's not the way you're meant to do it for a start. But as maybe as to the software team, do you write code, and when you're writing, you're always thinking, I'm writing a test for this, and therefore it needs that little maybe mindset change? Is that
there is a mindset that is that I was going to come to talk about in the next nugget, the idea of test-driven development, which is quite a rigorous approach where you don't write any tests, you don't write any code, or you write the minimum code to allow you to write tests, and then you don't write any more code until you've actually got a test that will test that functionality.
Yep.
So it's a real mindset change. So you're writing the tests first, and then you're writing the code to fulfill those tests. And you're writing more tests, which should start off on a unit test basis. You'd write all the unit tests for all of the functionality that you need, and then write the functionality to fulfill those tests.
Looking forward to that. That's what you're going to talk about next in the next one of these.
That's the plan was in the next one that we'd look at how to add tests to untested code, look at some design patterns and anti-patterns that can be useful, and then look at test-driven development, which is really the holy grail, but it's quite difficult to do rigorously. You need to change your mindset quite significantly.
Yeah. No further questions till then. I think that'll be really interesting to listen to.
Okay. Any further questions?
One last one from me, Steve.
Okay.
I like that you made a point quite early on in the presentation that I really liked, which was something about the test should kind of demonstrate the calculation. So you use the example, and like if you were just testing a function that was taking the sum of some numbers.
Yeah.
Defining the expected output, you would actually type out the sum of those numbers as opposed to just putting the result in. Mm-hmm. So the test kind of sort of documents the code in some way. And that example, I guess it was easy to understand what that might look like. But if you had a more complicated calculation, I'd be interested. And maybe just an example or some ideas about how you could achieve that without just rewriting the original code would be useful.
Copy and paste from your function.
That
was a lot of suggestions.
It's a suggestion, Ian, but the problem is that what we're really aiming for with that is to make your test understandable, make your test clean code itself. If you've just got one standard value in there, you're not really explaining what your code is trying to do. And you're right, it can be very difficult to do that whilst keeping your test readable.
I think we do have some examples, so we can put some on to the Yammer post or whatever. But yeah, it can be a challenge.
Yeah, that would be nice to see.
Yeah.
What we've done in Analyst Team is like just do it in Excel and then have the test read from Excel. So Excel documents it, but I'm not sure if that's good or bad really. It kind of works for us, but yeah. be nice to see some alternative examples.
Yep, we'll look to dig some of those out, Lee, and we'll include those.
Thank you.
One final question, comment, Steve. Can you share the presentation that you've
Yes, yes, we'll do. Yeah, it'll be up on SharePoint in the near future. Okay, any other questions? Right. Well, we will have a second nugget on testing, as I've previously said. As a result of Ross's question, we're going to be looking at how to add tests to untested code, some of the design patterns and anti-patterns, and also test-driven development. But if you have any other subjects that you do want to have covered in testing, then please let me know. Put them up on the Yammer group that we have, or just email me directly.
Cheers, Steve.
Thank you very much.
So, thanks everyone, and happy coding.
Thanks.
Thank you. Bye.